Welcome to this video on matrix transformations. Now I'm just going to go and cover some of the theory behind it very quickly, and then I'm going to launch into a couple of examples to hopefully help you understand matrices, stretches in the x and y directions, enlargements, and also rotations and reflections. Now then, the first thing I'm going to do is I'm going to draw this. Now this is what is called an identity matrix. And it can be used to maybe work backwards in a matrix puzzle and work out what one of the matrices are to make a different matrix. I'll probably do another video on that in the future just to help explain it, but for the purposes of this, that is what an identity matrix looks like. Now, I'm now going to draw a different one, which kind of works the same, but you'll understand what I mean in a second. Okay. Right, and as you can see, there's two K's. You're probably wondering what the K's are. Now, if I'm to draw this as two different matrices, I'm going to draw by the way, this isn't how you separate matrices, but for the purposes of this, I'm doing it for a certain way. Now, you're looking at that. Now, this represents a stretch in the x term, whereas 0k represents a stretch in the y term. So you're probably thinking, yeah, okay, that makes a lot of sense. So if I'm to draw, if I'm to draw, then I'm sure I could probably explain. I'm sure you could probably all tell me what it is. In fact, make K1. Don't know why I've written K. Then what it means is whatever your matrix is, or whatever your shape is, it has been stretched times 2 in the x direction. Or if I was to do, and that would be stretched times 2 in y direction. So you're probably thinking, well, how is this actually useful in matrices? Now there's one other thing that I'm going to go through very quickly which should probably help, and that is if it's 2, 0, 0, 2. Now I'm going to give you a couple of seconds just to quickly, try and work it out yourself, or you can pause the video, whatever's easier. Okay, you've had your time. This would be an enlargement scale factor 2. Now then, I'm going to go over two other things that you need for matrices. Now, you don't need to learn these per se, because they're in the formula booklet that you'll get for your further Pure 1 exams, but they are quite useful. This is cos theta minus sine theta cos theta. Now, this is what is known as a reflection matrix. Or should I actually, no, sorry, that's a rotation matrix. A rotation matrix. Yes, I know. I got a bit confused. Yes, this is a rotation matrix. Excuse my pausing and that kind of thing. And basically, what you do with this is you have different values of theta, and therefore you can learn, how much a shape has been rotated. So we're going to start with a very simple one. We're going to take then we're going to have, in fact no, we'll make life a bit difficult for you. Rather than putting in the fact that they're sine and cos, we're just going to write root 3 over 2 minus 1/2, 1 over 2, and root 3 over 2. Now, as is obvious, well, as it is quite obvious that there's a minus next to the half, what you now know is that it must be a rotation matrix, because there's a minus sign, and if you look at the one above, there's also a minus sign next to the sign. Minus sign next to the sign, excuse my poor attempts in humour. So what you would do is you need to work out, well, what is this minus 3 over 2? It actually look like a 3. You know, what actually is this? Now, there's an easy way of doing it. You just inverse cos and you inverse sine. So we'll do cos minus 1 root 3 over 2. Now, what this is, this gives you a result of 30 degrees. And the same if it's sine half equals 30 degrees. So therefore, you know that this shape has been rotated 30 degrees. Now, the way matrices work is it's not 30 degrees clockwise. Now, if it was minus root 3 over 2 and minus, if those two are minus as well, then you could say it was rotated 30 degrees clockwise, but it's not. It's only just those two, so I'll get rid of the minus signs again. So therefore, you know that it's been rotated 30 degrees, but because of matrix transformations, the shape has been rotated 30 degrees with paper anti-clockwise. That's probably more, you know, that is how matrix transformations work. Don't ever write clockwise unless you're sure that, you know, the matrix has been reversed, so you can write clockwise. Obviously, if you get like 180 degrees or something, then yes, you can write 180 degrees clockwise or 180 degrees anti-clockwise. It wouldn't make a difference. And yes, if you got 270 degrees, it probably makes more sense to write 90 degrees clockwise. But if you get an answer of less than 180 and it looks exactly like that, or should I say it follows that rule, then you know it is an anti-clockwise matrix. Now, we'll try another one quickly just to see if you get the hang of it. Draw the lines. Right then, now we've got minus a half, minus root 3 over 2, root 3 over 2, minus a half. Now, you're probably thinking, well, how do we do this? Now, we use the same principle, so we do cos minus 1 minus a half and sine minus 1 root 3 over 2. Now, both of these answers yield a result of 120 degrees, so therefore we know that, sorry, I hadn't realised the paper was out. So yes, I've drawn the matrix, and also we've got cos minus 1 minus a half and sine minus 1 root 3 over 2 equals 120 degrees. Now, as I've said, they go anti-clockwise, so the shape is rotated 120 degrees anti-clockwise. And a point that I've forgotten to mention actually on the other one, it must be around the origin. So yeah, I'll just quickly turn over again. So yeah, 30 degrees anti-clockwise around the origin. Excuse my messy writing while I try and make it so that everybody can understand incredibly easily. Right then, now you're probably thinking, well, what else can we do? Now, there is another type of matrix that you need to be aware of if you want to pass further pure 1. Now, this is something called a reflection matrix. You see why I got confused earlier? Yeah, it's that. The previous one was definitely a rotation matrix. The one I'm going to explain to you now is a reflection matrix. Now, I'm going to take the first example that we've got. So, the formula is, or should I say the matrix, again this is given in the formula booklet, so you don't need to learn it, but it's probably a good idea to make sure you do know it. Cos 2 theta, sine 2 theta, sine 2 theta minus cos 2 theta. Now, the matrix we're going to use to try and solve is minus 1, 0, 0, 1. Now, as you can tell, it doesn't look like your standard reflection matrix because the minus sign's the opposite side. But the point is that because it's minus 2 cos theta, then we know that probably is a minus 1, which means that we know that theta must be minus 1, or sorry, 2 theta must be minus 1. So we'll take 2 theta equals minus 1, and that sine 2 theta, sin cos, sine 2 theta equals 0. So solving it must mean that 2 theta equals 180 degrees, theta equals 90. So that means we know that it's going to be a reflection in the line. But as we know that the angle is effectively 90 degrees, then we know that if you draw a grid sort of thing, you have x, y. Now would be y. Now we know that it's a reflection in the line, effectively y equals tan 90, but it's because it's the positive x-axis, we know that it's a reflect in the y, because if we were to draw a right angle, then we'd know that that's 0 and that's 90. Or if you were to draw a cast diagram, then you'd know 0, 90, 180, 270. So therefore we know that it's a reflection in the y direction of, basically reflection in the x-axis of your shape. Now we're going to take another one just to try and make life a bit life a bit easier for everybody. Although this does get quite difficult, so if you're feeling like you don't understand, you're more than welcome to just stop the video, rewind a bit, and try and understand the method again. Or if you really do get stuck, you're more than welcome to write in the comments, and I'll try and solve any problems that I can. So we're going to take another matrix. We're going to take 1/2 root 3 over 2. Root 3 over 2 and minus 1/2. So as we know from earlier, then our reflection matrix is cos 2 theta, sin 2 theta, sin 2 theta minus cos 2 theta. But I'll write that down here again for reference. Right then, so you're probably wondering again, how do we do it? Well, we know that cos 2 theta equals 1/2, and we know that sine 2 theta equals root 3 over 2. So again, if you do cos minus 1, 1/2, and sine minus 1 root 3 over 2, then you should get an answer of, what is it? Yep, it's 60 degrees. But as you know, it's 2 theta equals 60, theta equals 30. Now this example works a bit better actually for the question. Now as we know from previous videos, sine theta over cos theta equals tan theta. So we know that effectively y equals tan 30. Effectively y equals tan 30x, or y equals tan 30, that's the line it's reflected in. Now, however, tan 30 is a value effectively. So y equals tan 30x is the line it's reflected in, but tan 30 actually has a value. So we can rewrite this as y equals x over root 3, because what it would be is tan 30 equals 1 over root 3. Therefore we can write this as y equals x over root 3, substituting in for basically the 1, and therefore that is your line of reflection in this, y equals x over root 3. Thank you very much for listening. I'm running a bit short of time on the YouTube thing, because otherwise I don't know what kind of mess I'm going to get into. So thank you very much for listening. I hope to see you next time.